Howdy folks, welcome to the next episode of Building Antic. Now, in the last episode, we talked about some of the environmental factors that have made building and manufacturing, particularly e-bikes in the United States, almost impossible. Well, today we're going to talk about how you actually go about setting up and organizing and designing and building a factory in the United States. I'm actually here in what is going to become the factory, which is really exciting. And so we're going to talk to Kyle, our CEO, a little bit about how all this is done and show you how we actually build the factory. Let's get into it.
So we are, of course, designing all the stuff that's going to go in the line, and then the line itself in CAD is like a tilting table. So we'll probably take a look at this in a little bit, but this is going to basically like unload the bike after it's been built, lowers it down to the ground, and then there'll be like a little ramp and you can just roll it right off. This is just one such project. It's not something we're buying. It's something we designed and built out of individual parts and electronics, motors, pneumatics, actuators, all that kind of stuff to build a helpful assembly aid for the Antic bike.
I'm here in the mechanical lab. This is where we design all the test fixtures and actually build the machines that build the machines.
First of all, we use a lot of 3D printed jigs and fixtures. All of this are material that we've already burned through on our Stratasys 3D printing machines. Over here we have our 3D printing print farm. All these machines are running basically 24 hours a day, printing all the stuff that will hold the different parts for assembly and stuff like that. So this is something called 80/20. Super helpful. You see it all around, industrial and commercial facilities because it's a modular system. It's kind of like Lego. So you slide in these little T-nuts and then you put like a bracket on top and then you thread into this and you can basically bolt together, big assemblies, including actually our full conveyor system is built out of this stuff. Because we're building Antic in the US, our labor costs are higher. So that's why it makes sense for us to invest in developing this equipment so that we can maybe do in 2 seconds what would take a person a couple minutes to do if they didn't have this kind of equipment. And then that lets us build them faster, build them better, and keep manufacturing here.
So before we popped in here, Kyle was showing me all of like the secret things, all of the secret, I don't know if they're text fixtures or like installation, whatever you'd call it, that we can't really show because we don't want to show everybody how we do everything. But can you show us that and we'll blur it out or something?
You'd have to blur it all out.
We'll blur it all out.
Okay. So we just finished getting all the electronics and pneumatics on here working, tested. And so it's just about ready to go over to the factory. So you press these buttons. If it works, nope, somebody stole my power. There we go. Click, click, and then all done. Easy peasy, right? That's so cool. One thing about building manufacturing lines, you get a lot of bills from McMaster-Carr. So if you haven't checked it out, McMaster-Carr is like this industrial supply mega store. I lied, it's not 2,000 pages. It's actually well over 4,000 pages. It is an American superpower. McMaster-Carr is the bomb. Shout out McMaster-Carr. Send me some merch.
Manufacturing is all about trade-offs. You have a certain amount of time, you have people, you have a space, a factory, and you need to figure out how to optimize all of that. Not only that, but labor and space in the United States is more expensive than it is in other parts of the world. So you actually have to be more efficient in order to offset it. Everything comes back to one factor, and that is how many units do you need to build in what period of time? This is called your build rate. And once you have this figured out, all other decisions come downstream of it. So if you're building 5 bikes per day, you're designing a very different factory than one where you're building 500 per day or 5,000 per day. We started this when we were building one wheels. We started on a fold-out table because we were making about 5 per day. And that entire process was done with humans by hand. But if you're scaling up and you're needing to build more units, say 5,000, then you need to invest more money up front into the systems and the machines and the test fixtures that can execute your manufacturing more efficiently. Okay, so you know your build rate. Now you gotta design a factory layout to achieve that level of building. All right, now this might look like a big empty room, and it's true it is, but there's actually a ton of work that's already gone in to making this space a manufacturing facility. All of the electrical drops need to be in their exact right place for where we've designed the layout of the factory. All of the lighting, all of the HVAC systems for when you're testing hundreds of batteries, all that stuff goes into the skeleton of the building. That's all stuff that we've done already. Now it's about designing the layout of the factory itself. So we're gonna talk to Kyle a little bit about that.
Manufacturing is a sequence of steps. You need to get all the material in, and then you need to put it together. You got your raw materials, RM. Okay, so then that feeds the line. The various parts that you need for an operation come in here, and the person puts them together. They add it to, whatever came into them from the previous station. So maybe they have to put in a couple screws, or maybe they need to install a circuit board, or maybe they need to install the fork on the bike, or whatever. There's something called tack time. So if this task, putting a couple screws, that takes 30 seconds, but the next task takes 7 minutes, you're not gonna be able to transfer the thing that you're building between stations in a consistent way. So tack time is how long each station has to do their work before it goes to the next station. So that 7-minute job, that either needs to get split into a number of individual tasks, or it needs to be done offline. So maybe you have a sub-assembly cell basically over here that's building something up, and then these things already built up get transferred to that station and just get dropped in so that you're able to align the timing of it all. There's around 35 assembly steps in building an Antic bike, the way that we've got it designed so far. And yeah, we're working on integrating all the special equipment that we've designed to do it and getting them flowing out the door. This is how the plan works, and then the big project is to make all this exist in real life. So these are all the 80/20 aluminum extrusions we're looking at in the shop. Lots of plastic plates. It doesn't scratch the parts that are making their way through there. Of course, it's all kind of modular. So after we get into production and we kind of learn if there's bottlenecks we didn't think of or whatever, or things we need to adjust, we have some flexibility to change it up a little bit and get more Antics flowing out the door.
Alrighty, folks, so it's been cool to have the cameras out for the last couple weeks and just kind of document what the process has been like really over the last month. Designing the layout, designing all the fixtures, how it's all gonna flow, and then building the machines that are actually gonna go into the factory. It's been ramping up, and we are very close to loading all that stuff up here in Santa Cruz and taking it over the hill to San Jose and actually getting it set up in the factory and getting that all running. So that'll be next episode. We're getting close. Thanks for sticking with us. Can't wait to get you on one of these, and I'll see you in the next one. Kev, you gotta get my wheelie. Ready?